Hello everyone. In this video, we'll construct a DFA for language consisting of strings ending with the particular substring. Okay. So whenever the problem is given like this, which ends with particular substring, so you just have to first of all count the length of the substring, count the length of the substring, okay, and then remember that your number of states need to be suppose the length of the substring is n, the number of states would be n plus 1. Number of states in the DFA is n plus 1. And then first of all, while constructing you have to construct the DFA for the substring. For example, you have to construct initially the states for substring. So that I will explain with an example. Okay. Now here the first example 1. Okay. So here I am going to draw a DFA or DFSM for the language accepting strings ending with BA. Okay, ending with BA over input alphabet, that is sigma over sigma equal to A comma B. Okay. Now the solution. Let's see the solution. So as I told, the length of the earlier you have to count the length of the substring. So length of the substring here is BA, because I have told it is you are going to construct a DFSM for the language accepting strings ending with BA. So that means substring here is BA. Okay, length of this substring is 2. So the number of states need to be 2 plus 1, that is 3. 2 plus 1, that is 3. Now let's start building the states. Okay, or I can say let's start building the DFA. DFSM first of all, as I said, I will write the states. I will start with the start state. As I said, first you need to construct, initially build the states to identify the substring. So first character of substring is B. So that's why we use these 2 states. To identify one character, you need to have 2 states, and then you need to identify A. So this is the ending. Okay, it has to end with this. So you can observe here there are 3 states. Okay, now since it is DFA, in each state it has to take a transition on all the characters. It is, if you see here, at Q naught, it is already taken as transition on B character, but not A, So now what you have to do? So you know that at Q naught, isn't it? If you get A, any number of times A, obviously you can't give a transition on this path, for A. What happens? If suppose if I build A here, then if I write A here, then what happens? This entire thing can also recognize AA. It can also recognize strings ending with A. That should not happen. That's why what if I take a character on a loop, A character on a loop. Okay, so you know that you can get in the beginning, and to move to the next character you have to go this path. You have to go through this path. So in the beginning, any number of times you get A, that is okay. Suppose something like this, A, B, A, that is fine. A, then it is going to take this path, B and then A. Okay, so at Q naught it is fine. Then coming to at Q1 has already taken a transition on A but not on B. So what if I take obviously I cannot take a transition on this particular path. B is not possible, isn't it? So next what? What about back path, that is back transition? That is also not allowed, isn't it? That is also not okay. Why not okay? So then it is always going to take after A, any number of A. If I take a back path here, okay, with on B character, then it is always going to take a odd number of B's. That is also not okay, because that will never recognize even number of B's and A. So that is not allowed. So that cannot be done. So we want even number of B's as well as odd number of B's. So that's why best way is taking a loop on B transition. Okay. So now here you can see that Q1 is also has taken a transition. Q1 also has taken a transition on B. So both the characters it has taken. Now coming to Q2. What if Q2, right? One or more character. That is, if I get B, after getting B, A, if I get B, then what? Then there may be a possibility that you will get A again. There may be a possibility that you will get A again. So you can take a back path here, B, then A. So suppose if you do not get A, then obviously it is going to stop at a non-final state. Okay. So this is for A1, A character, B character. Then what if after getting sometimes A, B, A, there is a possibility that after reaching here, there is a possibility that you will get any number of A's, then BA. So what you should do for that? So again, you should start recognizing BA from the beginning. So if you get A, you have to start from the beginning. So this is what the DFSM should be for ending with BA, for ending with strings ending with BA. So you can observe here what kind of strings it is going to match. First of all, let's build some strings that is matching with this particular problem. So L equal to 1 is the smallest string of this is BA, ABA, BBA, AAA, BA, then BA, BA, all these, right? So now let's try BA, one of the string, it matches, fine. Similarly ABA, 1A, B, and then finally you are at the final state, that's okay. finally you are at the final state, as well as your input got exists. Suppose if I supply a string like B, B, and then A. Finally, your input got exhausted, as well as as well as you are in the final state. Next, A. Next, B, A. Okay. So these are some possibilities I have checked. Okay, and remember, the combination satisfying this particular statement should be matched by the DFSM. So when you, or I can tell, should be accepted by the DFSM, and the combinations that are not according to this particular statement, then you should end in non-final state. Let us write the quintuple on this particular DFSM. Okay, so Q sigma M equal to Q sigma delta S comma A. So these are the 5 tuples. Okay. Now the quintuple. Okay, the Q is nothing but a set of states. So M can be written as Q. Q is nothing but set of states, that is Q0, Q1 and Q2, all the states that are present in the DFSM. Sigma is nothing but alphabet, that is only 2 characters. You can see we have already told the strings are over alphabet A, B. So A, B. Then the delta we are going to write later. Then the start state of this is Q0, because you know that start state should have an arrow like this. So that is Q0, and then the final state is double circled, that is Q2. So now let us try to write a delta. What is delta? Delta you have to write for each transition that exists in the DFSM. First of all, I will write for Q0. So Q0 on A goes to Q0. Okay, this is one transition, and then Q0 on B goes to Q0, Q0 on B goes to where? It's Q1. Q0 on B goes to Q1. Next, comma, Q1 on A goes to Q2. Q1 on B goes to Q1 itself. Q1 on B goes to Q1 itself. Okay. Next, final Q2 on A goes to Q0, comma, Q2 on A goes to Q0, Q2 on B goes to Q1. So this is the transition, and that the same transition function we can even write in the table format. Okay, first of all, so the rows will be represented as states and columns are represented as input symbol. Okay, input symbol. So what are the states we have? Q0, Q1 and Q2. And which is the start state here? That is Q0, that need to be marked like this, and the accepting state need to be marked as as star, okay, or sometimes people will mark with the circle, okay, and then A and input symbols are 2, that is A and B. So now you have to see Q naught on A goes to where, that is Q naught. Q naught on B goes to Q1. Q naught on B goes to Q1. Q1 on A goes to Q2. Q1 on B goes to Q1. Next, Q2 on A goes to Q2 on A goes to Q2 on A goes to Q naught. Then Q2 on B goes to Q1. So this is how the table will be. And at the end, we'll try to do a computation on the table or a DFA. By looking at the table also you can do, or using the DFA. Now we'll see the computation on the string BBA. That is, I am going to verify whether the string is according to the language or not. So that's why I will consider now the computation on input BBA. Okay, looking at the string, obviously it is clear is if this particular DFA is correct, then it has to be accepted according to the language. Now, so that's why I will start from the start state. Start state of the DFA is DFS or DFSM is Q naught, and then the input, Okay, next Q naught on B goes to where? Q naught on B goes to Q1. Q naught on B goes to Q1. So Q naught on B goes to Q1. So we finished processing this. So what is remaining in the input part? That is only BA. Next, Q1 on B. Q1 on B goes to itself. So Q1 comma A. So Q1 on A goes to where? So Q1 on A goes to Q2, and what is remaining in the input part? That is epsilon. So now you can see that at the end you have reached the final state. Right? Final state is Q2 of the machine. Reach final state, and input is empty, right? So that means input is exhausted. If so, input is exhausted. If so, you can tell that this particular input, that is BBA, is accepted by the system. Remember, both the condition need to satisfy. So here it should come to a final, you should reach to a final state, and you should process all the characters of the input. Finally, you should get empty. So this particular input has been accepted by the system. Okay. Next, we'll see computation for one more string. So this time I will consider the input that is not in the language. Computation on input BA, not BA. BA is according to the grammar. So I will consider now input A, simple input. I will consider AB. So start from the start state, and the string is ABA. So this can give you Q naught on B goes to Q1, and what is remaining in the input, that is Q1. Q1 on A goes to Q. This is AB. This has to be AB. Okay, so Q naught on A goes to where? Q naught. So what is remaining in the input? That is B. Okay, that is B. Now what about Q naught? What about Q naught on B? Q naught on B goes to Q1. Q naught on B goes to Q1, comma, what is remaining? Nothing. So now you're in the final state and you're not in the final state, non-final state, and there is no input to be processed, input character to be processed. So this kind of a state says that this particular string is not accepted by the system. Not AB is not accepted by the system. Since it is in non-final state, since you have reached to a non-final state. Okay. So that's about the one example. Next we'll consider another example. Example 2. Now we'll see how to draw a DFA to accept strings of A's and B's ending with BAB. First of all, what's the alphabet here? Alphabet that what we are going to consider is A and B, because it is saying it is going to a particular DFA or Dfsm, whatever you are going to construct, it will accept strings of A's and B's ending with BAB. Okay, so the alphabet here is AB. Next, second one, let us decide the number of states. Let us decide the number of states. So for that, let us decide the number of states. Okay. For that, the length of the substring is, the substring what we are going to consider here is BAB. Length of substring is BAB. That is equal to length of BAB, that is 3. So the total number of states, required in the DFA is 3 plus 1, that is 4. Okay. Now, as I told, let us first initiate the DFA. Let us first initiate the DFA by constructing the states for BAB to recognize BAB. The BAB, for the first one, you start with the start state Q naught. First we'll identify B, right? Next the another character Q2, and after that BAB. Okay. So remember, the calculation of number of states changes according to the problem. So here we are going to construct a DFA for that contains the keyword ending with. So I am going to deal with only those kind of problems. So in that case, number of states becomes 4. The number of states can be changed if the keyword is starting with. Okay. So now BAB. So now, as I told earlier, that each state has to take a transition all the characters of the alphabet, whereas Q naught has taken a transition on B but not on A. So in the beginning you can have A. So before getting B, if you get many A's, fine. So as I said, it can't be on the same transition, because that time what happens, if I write here A, so it will but is by taking A, it can move to the next state, then it can even end with AAB. That should not happen. Now A has to take a loop here. Next, coming to this, what about B? Any number of B is fine, then you can get AB also fine, because finally you want to end with B. Coming to Q2, B it has already taken a transition. What about A? So suppose if it is A, okay, suppose if it is A, it can't be in here, it can't be here as a loop, right? It can't be as a, suppose if it is A, it can't be as a loop. Why? Because If I write here as a loop on A, then B also will be accepted by a system. So if I write here A, okay, then what happens? This particular DFA is going to accept even B. Such kind of a string also it is going to accept. That should not happen. We want to we want a strings that ends with BAB. So A here is not okay. Okay, can I shift to this path? No. Then again what happens? It can take B. Such kind of a string will be accepted. So A, no. So the proper one is taking, again you have to start recognizing the string from the beginning, Okay, so A. Next, here A also done, B. Next is, what about after this B. If you get A, again go back and start from the beginning. Okay, go back and start from the beginning. A. Okay, this is fine. Next, B. If you get, then again after that what you expect? AB. So that's why it is better to take a transition to from the last state, that is a final Q3 state, better to take a transition to Q1, and then it is from BAB. It can continue like that. Okay, this is the DFA to accept the strings of A's and B's ending with BAB. Okay, next we'll perform the computation on some string. So what are the possible strings? Computation on some strings. So let me take BA. So whether it is accepted or BAB. Okay. So let me take this. So initially you need to start from the start state. Okay. BAB. Then Q naught on B goes to Q1, comma AB, BAB. Then comma Q1 on A, Q2, BB, AB, comma Q2 on B, Q3, BAB, comma Q3 on B, goes to Q1, comma AB, Q1 on A, Q2, comma B. Next, comma Q2 on B, Q3, 3, comma empty. So you can see here this is a final state, and finally you have reached a final state, and this input has exhausted. So that's why we can say that this is particular, because of these two reasons, what you can say that this particular string BAB is accepted by the machine. Okay, let us write the quintuple. We got to write a quintuple for a machine. M, Q, sigma, delta, S, comma, A. What is Q? All the states, Q naught, Q1, Q2, and then Q3. What is sigma? The alphabets. Alphabet is A, comma, B. What is delta? We'll write later. S is the start state, Q naught, and then the accepting state is Q3. Okay, where delta equal to, I will write in the form of transition table. So Q naught, Q1, Q2, and then Q3. Okay, so only two input symbol, that is A and B. Q naught on A goes to where? Q naught on B goes to Q1. You can see here Q naught on B goes to Q1. Q1 on A goes to Q2. Q1 on B goes to itself then Q2 on A goes to Q2 on A goes to Q0, Q3 on A also goes to Q0, Q2 on B goes to Q3, then Q3 on B goes to Q1. So this is about the problem, that is problems related to the keyword ending with. Okay, so DFFR languages consist of strings ending with the particular substring.